E equals mc squared. It says the energy of a body, E, is proportional to its mass, m. It implies nothing can travel faster than the speed of light. You know that's C, don't you? Because it would require an infinite amount of energy so to do. What the team at CERN has seen is subatomic particles called neutrinos breaking that rule, travelling a tiny but significant fraction faster than the speed of light. They've repeated the experiment. They weren't sure. They wanted to check it. They checked it 15,000 times and brought the same result in each and every time. If their results are found to be accurate, it would turn physics on its head, say many. The question now is, has Einstein been wrong all along? David Whitehouse is alongside me. These are two massive stories. We'll get onto the space junk in a moment, which I know you feel we're underplaying. Let's talk about this speed of light story. You think it's massive?
If this is true, it is an earthquake. It's a revolution in physics. This is one of the great changes in physics, on a par with Einstein's discoveries, his theories 100 years ago, and the discovery of the quantum world. Einstein said in his special theory of relativity, nothing can travel faster than light. The only reason light travels at light speed is because it lacks what we call rest mass. Any physical object cannot get to the speed of light. And the idea that these experiments, and they're good scientists, it's a good experiment, they've looked through every aspect of their experiment to see what could account for this and can find nothing, and they've put it on the internet to other scientists to say, look, see if you can find anything. They cannot. If it is true that these strange particles called neutrinos actually
go through anything.
Can go through anything. They're ghostly particles. They're difficult to make. They were created at the Large Hadron Collider, and they're fired 720 kilometers through the Earth's crust
to a laboratory that's nearly 5,000 feet underground.
That's right, to a detector that's underground to keep it quiet and still in Italy, and it got there before they thought it would, before light would.
But we're talking billionths of a second.
It doesn't matter in the sense that it doesn't matter how small it is, faster than light. The fact it is close to light, or just over the speed of light, changes our fundamental understanding of the way the universe works.
Time travel possible?
Yes. Everything is now open for...
I've been waiting years to ask that question, and you just say yes.
It is, because speed, time, the speed of light are all linked, they're all relative, they're all axes around which all the laws of physics in the universe rotate, are based.
Okay.
And if we can go faster than the speed of light, then fundamentally it changes our fundamental understanding. Time travel, faster than light travel, exploration of the universe, amazing world of strange new physics opens up in front of us.
And it really is a reminder, were it necessary, that nothing's for keeps in science.
This is it. The lesson from science is, as soon as you think you've got it nailed down, as soon as you think that the Earth is the centre of the universe, that Einstein's theories are correct, that the quantum world, you know, all these things, as soon as you're arrogant enough to think that you understand the universe comes along and shows you you're not right, and there's a new level of understanding. And there's a young generation of scientists who actually, for years, have said, we're just tidying things up. Where are the great revolutions? Well, this is their opportunity. This, if it's true, could be the great revolution they've been waiting for.
And in a sense, leaving aside the risk of instrument error, the point is, it doesn't matter how much quicker you go than the speed of light, it's the fact you are breaking that barrier.
That's right.
That's the key thing here.
It's the fundamental thing is that something, a neutrino of all things, that we thought we understood reasonably well, if it can travel in certain circumstances or a certain fraction of the time faster than the speed of light, the principle has been broken.
Okay.